Great.
All right. Hello, everyone, and welcome to another episode of Building Educator Capacity, where we strive to improve student learning by expanding the capacity of our diverse school districts. We're out here doing another live podcast to celebrate the year of math. I'm coming at you from an educator recruitment fair where we have more than 20 school districts and 150 educator candidates connecting. So it's a very busy day at CISA 2. Nevertheless, we really want to celebrate the year of math, and so we are back here with Molly Rilling and Matt Hayden, continuing the celebration. And today we have math experts Eric Milo and Steve Leinwand, authors and mathematics experts, chatting the madness of Algebra 2 in high school math. With that, let's get right into it. Molly, take it away.
Hello, thanks for coming, everyone. And we are so excited to host Eric and Steve. We are going to jump right into some topics shortly, but just to give a brief background information, we're going to start off with my favorite, a little connector. And then once you jump into that connector, you can tell us a little bit about your background and how you ended up in your current role. So our connector, to start us off, is going to be math related, of course. And that is, what is your favorite number and why? So let's start with Steve. Why don't you go for it?
So I just think that the clear proof of my nerdiness is the fact that I just think pi is an amazing number. It's the first irrational number I ever knew about, which meant that it was like long and weird and didn't repeat. It never ended. It didn't have a pattern. And yet it was so simple. I mean, it's just this ratio, no matter how big or small the circle is, it's the ratio of the circumference to the diameter. And yet over math, it just pops up over and over again. And every time it would pop up, like in trig, or it would pop up in something else, or it would pop up in these crazy formulas, it just blew my mind. So I just think pi is sort of a proof that there is a God.
And it's almost Pi Day, right?
That's
So that's
correct.
coming up.
Can't wait.
All right, we'll pass it off to Eric then. Eric, favorite number?
Uh, you know, I'm just gonna go back to high school here. And it's quite a while for me, but I remember my high school teacher so well. His name was Mr. Bro at Haverford High School in Pennsylvania. And he would always say 17 thirds, no matter what the damn question was. Okay. We be doing, evaluate f of x at 2x minus 3. We could do f of 1, then we do f of 2. And then you go, okay, we got to do f of 17 thirds. Okay. Every single problem we had to, he would always put in 17 thirds. And he would say, you think it's going to work for 17 thirds? You think it's going to work for 17 thirds? Every other day it was 17 thirds, 17 thirds, 17 thirds. I think it was a way to say to us that it's not always about natural numbers. It's not always about integers. You have to think that numbers aren't just 1, 2, 3. 17 thirds is just a number. Why do we think 17 thirds is so ugly? Why do we not like 17 thirds? And he made us really think that 17 thirds is not ugly.
That's wonderful.
Yes, I appreciate both of those answers if we're going outside of the box there with some decimals and fractions. So that is great. Rolling right into some of our content for today. So you both are authors of Invigorating High School Mathematics, and we want to talk about, how did you get there? What's your background and how did you end up in the role that you have today?
Steve always goes first.
Okay, Steve, go for it.
So I really liked math in high school. I was one of those nerdy kids that found it easy. I had the most amazing calculus teacher who was like the capstone of all that stuff. And so you go off to college and you figure, hey, I'm going to be a math major. Makes sense. Freshman year, I had honors calc 3. And I ran into Stokes' theorem, and my math career basically ended. I just don't understand that finite differences stuff, and I've tried to go back, and it's just is over my head. It was an incredibly wonderful lesson freshman year of college that math wasn't really for me, and that I know now as a teacher that everyone hits that wall somewhere. And so I switched to economics and was going to go to business school. And then in the wonderful late 60s, early 70s, with all this stuff going on, it made absolutely no sense to go to Stanford Business School. I really loved the math, and I fell into just the right position at the right time. I had taken another math course, so I had just enough credits in math to be able to get certified. And my career has been very simple. I ended up where I am right now because I have been truly blessed and incredibly lucky. I've had 3 jobs. I taught in the 70s. I was the director of math or the math supervisor or the math consultant, whatever we called each other at the time, for the Connecticut Department of Education in the 80s and 90s. Stayed for 22 years. I burned up bridges, and we moved to DC in 2001. A year later, I got a job at the American Institutes for Research, and I spent 22 years at the American Institutes for Research. What's coolest about all of that is that I've had 3 jobs. I have never been promoted, and I have never applied for any of those jobs. And so I know how lucky I have been that people have sought me out for those jobs. Every time they said, we have to promote you, I said, you promote me and I will quit, because I was ready to teach the rest of my life. I was ready to run math in Connecticut for the rest of my life. I was ready to stay at AIR. But you get to the point where enough is enough. And now I freelance. Most of my work is pro bono. It's really wonderful. I do lots of mentoring, and I still do some writing, thanks to Eric. And I keep myself fully involved and engaged. But I have been in well over 3,000 schools in that 50 years. I have been in thousands of classrooms. I have co-taught thousands of classes, and I have written thousands of items. So that's where I am, and I'm looking forward to tonight, because I think that high school math and assessment are the 2 giant obstacles that we have to solve if we're going to make math work in this country.
Yeah, and I could tell a very, very similar story to Steve, and how much I loved the mathematics in high school. But it was the other side that interested me so much. It was like all the kids that hated mathematics in high school, the majority of them, and they would always look to me to help them. And I always thought, like, why do you hate this stuff so much? It's so amazingly beautiful, but the majority of people hated it. And I loved it so much. And I not only loved the mathematics of it, I loved being able to try to explain it to someone else in a way that they could make sense of it. And I got lucky. I went to Franklin and Marshall College, had tremendous, tremendous mentors. Graduate school, going to do a PhD in math similar to Steve, and I ran into a wall. And I said, oh, what about this math education thing? What about this thing? What about this idea of working with teachers? And I met a wonderful professor at Temple, Stephen Krulik, rest his soul, the most amazing professor ever. And I've had one job, Steve. You know that. 30 straight years at Glassboro State College, which is now Rowan University in southern New Jersey. And just being able to work with thousands of teachers in New Jersey and around the country. And it's that same theme. I love it so much, but so many of you hate it so much. And that's really the theme of this whole webinar. It's like, why 30 years later, 50 years later, 100 years later, do we still have this issue with mathematics that so few of us love it, but so many hate it?
Yeah, that is a great question. And that is why we brought you together, right? As high school math experts, because I think when we think about mathematics, or even some of the folks that Matt and I work with too, we're constantly thinking, like, where is the fall off of this love for mathematics and this joy and this wonder that kids bring into that classroom? So, Steve, you started to allude to some of those reasons or some of those issues that you're thinking about right now with mathematics, or hoops to jump through. What do you think, both Steve and Eric, and we'll start with Steve, are some of the current overarching issues with high school math?
Well, I mean, the list is really long, and it needs to be clear that this is not teacher bashing. Teachers have been set up. Teachers have been given minimal guidance. Teachers, in fact, have been told, teach to a stupid ass test. And so, I mean, we have got ingrown systemic issues and problems. But it starts with the scores are abysmal. I mean, the SAT, your raw score to get a 500 on this test is like, out of the 60 tasks, you only need to get like 27 of them. And it's crazy how low those standards are. It's and yet you got all these kids that can't even come close to a 500. You've got the same issue with all the other tests. Things are halfway decent in fourth grade and eighth grade, and then by the time we get to high school, the kids don't care anymore, and they're bored to death. And part of that is our problem. I mean, we are boring kids by telling them that they have to learn a factor, that there's two ways you have to learn, even though no one does solving systems equations in two different ways. We don't have much context. We don't have much fun. It's a whole lot of see, I tell, I show, and you practice. And so when so much of the curriculum and what is done in math class is skills and symbol manipulation that today are done by machine. I mean, the biggest problem is that kids can get proficient on almost every test we give them with Google, to say nothing of AI, or with photomath. And so they are smart enough to know that this is just stupid. And many of them have got parents or older brothers that say, hey, just go use this tool, just go get the answer and all that stuff, because we don't ask why, how do you know? The problem is that we have a world that's saying it is essential that kids be able to communicate, to reason, to find alternative approaches, to be able to justify their answers. And we don't ask why. It's all multiple choice drivel. We do not have a focus on how did you do it? How did you do it? How did you do it? It's all so much of just the same old, same old. In fact, I should have put this out. So we're in Santa Fe last weekend. There it is. And so we always go to see what's new in the postings in the Georgia O'Keeffe Museum. So I'm walking around there with my wife, and there is a quote from Georgia O'Keeffe on the wall. You ready for this? Georgia O'Keeffe, sheerly amazing, truly brilliant. You write about my flower as if I think and see what you think and see of the flower. And I don't. I read it a couple of times. I took the photograph. And all I want to do is say to you, so you teach about fractions, teacher, as if I think and see what you think and see about fractions. But I don't. I need you to validate and use what I see and what I think if I'm going to learn. And we've not been able to win that battle. And so we have a program that sorts rather than empowers. We have this incredible imbalance between the rigorous pre-calculus approach, which is, just mind-numbing in so many ways because it's all driven by a calculus AP test that has less and less value, certainly compared to the AP stat. And we don't do anywhere near the amount of data and stat that we do. So we have a whole range of issues. And I know that this is a double-edged sword. Most teachers fully understand that. Most teachers are well aware of it. They're frustrated by it. They know they can't cover all the crap in their textbooks. They don't know how to pick and choose. They know that kids come in underprepared because it only takes 1 weak 7th grade teacher to make a 9th and 10th grade teacher's life miserable. And yet there's that side that says, but what do I do? And that's where I think we're going to make some progress tonight.
Yeah, just to sum up that, there's two themes going on there. There's one, there's a curriculum in the year 2026 that looks like 1926. There's really very little difference. I went to school in the 70s and 80s in a Dolciani textbook. Some may know the name Mary Dolciani if you don't Google it. And the textbooks look the same today. We're doing the same nonsense, even though it's 100 years later or 50 years later, and the society has changed so much. But yet we are still stuck in this world that we have to do these things just because we've always done them. So there's the antiquated curriculum. But since Steve threw out a quote, I have to throw out a quote also. This is a quote by F.E. Marshall. And here it is. What I wish to urge today is first, that telling is not teaching. And secondly, that there is great waste of the pupil's time owing to the useless of clumsy methods which he is taught to use. Now you can probably tell from the English there that it's not that young of a quote. This quote is 1893 by F.E. Marshall. And what is F.E. Marshall saying in 1893? That telling is not teaching. And there is such a great waste of the clumsy methods which the student is taught. 130 years later, that quote could still be said today, that we are still doing telling, teaching by telling, and a bunch of clumsy methods. And boy, that's one thing 130 years later we could change tomorrow if we wanted to.
So I know, Molly, that you're going to move from these general high school issues to Algebra 2 issues. Allow me to just provide a transition from everything that Eric and I have just said, and use Algebra 2 as an example. I mean, the question that we as teachers of mathematics need to wrestle with is, why the hell in 2026, 27, 28, do we tell kids that 1 over root 2 is wrong, and that it has to be changed to 2 over root 2? And what kid actually believes that 2 over root 2 is 1 iota simpler than root 2 over 2? And that sort of is a microcosm of the absurdity of the curriculum in a world of technology still predicated on crazy rules that grew in the 30s, the 1930s and 1940s, and have just continued on right through. But that notion of simplify, what do we mean by simplify? What is simplifying? Okay, why are we rationalizing denominators? Seriously, why are we sitting there and saying that, in fact, 5 over 2 plus radical 2, all I really care about is that you're able to say, oh, look at that, 5 over 2, radical 2, 1.5. So 5 over 3.5, well, that's going to be 10 over 7. Oh, yeah, look at that. It's about 1.5. Whoa, look at that. I mean, that's the kind of understanding, because then when I put it into my calculator, I know exactly what it is. This idea of multiplying by the conjugate and being told you're wrong or you're dumb, the way in which we do synthetic division that nobody does. No calculus teacher expects to see it. Simplifying rational and radical equations, trig identities. I mean, trig identities today is going to Desmos, going to graphing calculator, and typing the functions in, and when they overlap, then yeah, they must be the same. They must be okay in some particular way. So I just I think that those kinds of examples, factoring with leading coefficients of quadratics, not one. Those are some things that I think most teachers believe are just not there. And then that when we do all that stuff, we don't have time for data, we don't have time for statistics, we don't do any kind of modeling, and math ends up being in this ridiculous rut. And the bottom line is, Algebra 1 is easy to fix and is being adjusted in lots of ways. Geometry doesn't need a full year, but some of the things that would fit in 2/3 of a year of geometry are still so important. Algebra 2 is this monster. Either you get it and you have to take it to get the calculus, and you realize that this is really not the math that normal people love and do, or it is a giant obstacle to the rest of your life, because you're smart enough to know that you're going to be a social scientist or interested in those things, or you're going to be in some other career. I mean, you want to go do nursing, you need to go ratio and proportion. You don't need to simplify quadratic expressions and do exponential functions the way in which we do them. You need applications of exponential functions. So that's the bind we're in. And the good news is the Common Core and history and common sense, K-8 is in damn good shape. We still have to do a better job with instruction. We need to change the assessments. But I mean, what the Common Core did for 6th, 7th, and 8th is truly Herculean and wonderful. We have not been able to change 9-12, and the Common Core helped us know. The Common Core set us backwards in terms of all of these things at high school.
Yeah, thanks for sharing that perspective. And I hear sort of you're talking about the what a lot of instruction, and Eric's also bringing in the how of instruction with his quote there as well by F.E. Marshall, I think you said. And we also appreciate the quote from Georgia O'Keeffe, because she is from our local Wisconsin, if you didn't know. So shout out to Wisconsin there. And you're also talking to a bunch of teachers who are in ACT week right now in our state, because that's our high stakes assessment that we use. So lots of connections going on there between the curriculum, the assessment practices, and also the instruction. Eric, did you have anything to add to what Steve was saying at all before we sort of transition into this question about why is Algebra 2 the problem and just expanding on that a little bit more?
Well, let's jump right into that.
All right.
Right. Go, you want to rephrase the question?
Sure. So we're talking about high school mathematics. Let's narrow in here to Algebra 2. So when we think about the Common Core and K-8 having things pretty much fleshed out there, and we are thinking about high school, and there's opportunity to change or has been some fluctuation in Algebra 1 and geometry. What happens in Algebra 2? What is our current issues with Algebra 2 as it is?
There's so many issues. God, we need about 6 weeks of podcast here, but let's just simple it down to a couple issues. Um, uh, Look at the curriculum algebra 2 and look at the needs of society today. Now, let's face it, there was always going to be kids going into STEM majors. Yes, and they're going to need algebra 2. They're going to need pre-calculus and calculus. And Steve and I, sometimes we get criticized for saying that we want to do away with calculus. And like, that's silly. We don't want to do away with calculus one bit. We always want kids in STEM majors to go in that direction. Absolutely necessary, absolutely required. But what percent of kids is that? 20, 25% of kids? What percent of kids is that? And in fact, we have 100% of kids going in that direction. We have 100% of kids sitting in Algebra 2 class. Why? Why are they learning to do obsolete skills when they could be doing some really, really great mathematics from data science, from quantitative literacy? And Steve will make hopefully an argument that quantitative literacy is necessary for a democracy. There's actually a straight line between the two. And kids not going to college, kids going into communications, kids going into trades, kids going into sociology, kids going into psychology. These are non-STEM majors, and they're sitting there factoring. Are you kidding me? We could do better, and we should do better, and we should be mad on behalf of those kids that we're not doing better, that we're continuing to give them an obsolete curriculum. When in fact, the quantitative literacy needs of students today and of the world today are so much in demand. Not changing the pathway to STEM. We're not changing the pathway whatsoever for those kids. We are supporting kids who have chosen other ways to go. And we are supporting those kids with mathematics that is wonderful, that is beautiful, that is just as wonderful as factoring, except they're not going to factor.
Yeah, and I would say even bringing in the local context here too. So we have Wisconsin Mathematics Council, and then there's a Wisconsin Math Alignment Task Force as well. And even some of the work that's come out from those, there's been a college readiness statement that was released, and it was a K-20 effort. But thinking about from what those professors were saying is let's pause on this race to calculus idea and really focus on math instruction within high school and really rethink that STEM acceleration for the purpose of accelerating to get to high school calculus instead of is there an opportunity even to rethink what that looks like in college instead? So that local piece there.
So let me build off of what Eric just set the table with. I have 4 points. Point number 1 is to reiterate what Eric just said, and that is we start with this idea that if you look at the content, Algebra 2 is just out of sync with societal and workplace needs. It doesn't focus on communication or reasoning or justification or problem solving or modeling or any of those things. In fact, Algebra 2 serves exactly the same role that organic chemistry does in terms of guaranteeing that doctors are not humane in many cases. And that's a horrible statement. But when you have to get through organic chemistry to become a doctor, it's no different than you have to get through Algebra 2 and all of its silliness in order to go on with life. And it's just a problem. I mean, the best news is that less than half the states require it, which is good. But the number of kids that are in states where it's required is a nightmare. Number two was the whole question of math for all. I just want to be a little bit historic here and generalize. In 1900, when 10% of the society graduated from high school, math for all was K6. everyone needed what happened in K6. You get to the 30s and the 40s, and the world is a little more complicated, and significantly more kids are going to college and all that kind of stuff. Math for all in the 30s and the 40s became K8. All of a sudden, we didn't have an agrarian society. You really needed eighth grade, 8 years of math plus kindergarten and all. I think it's pretty clear to everyone today that the math for all is K10. And Eric and I believe very, very strongly that we have an integrated program in K through 8. 8th grade, 7th grade, those Common Core, there's statistics, there's numbers, there's algebra, there's geometry. And we think that has to continue, because when you look at statistics for 9th and 10th grade, algebra for 9th and 10th grade, and geometry, this idea of the math that everyone in this society needs is not just Algebra 1 and geometry. It's an integrated algebra, geometry, integrated algebra, geometry, statistics. And that is the math that everyone needs to have, which now says that means that in 11th grade, there have to be pathways, because everyone leaves 5th grade and goes to 6th grade, everyone. So there needs to be some coordination, and everyone has to do that. Everyone goes from 8th grade to 9th grade, 100% of the students, so that there's got to be some coordination. But what everyone leaves high school and goes from a community college to the military. They go, different tasks, different pathways. They get a job. No, they're not in the workplace. They go to a STEM major at a community college. No, they're going to go to a high class college. They go to the University of Wisconsin, and they're going to take music and art. No, they're going to do psychology at the University of Wisconsin in one of the non-Madison campuses. And so you've got this amazing array of both math focus, non-math focus, and what you're going to do with your life. And all of that suggests that we have to recognize that Algebra 2 is mostly beyond the line of math for all. It's math for some, when the other math for the other some is more of this data and statistics. Number 3, I think we have to be very clear that Algebra 2 continues to be 1/2 a year of a 2-for-1 dilation of the entire Algebra 1 curriculum. Everybody knows that. We basically reteach the same damn course, except that in the last 10 years, Algebra 1 has moved into 8th grade and 7th grade. The Common Core has given half of the Algebra 1 curriculum to 7th and 8th grade, and about a third to a half of the geometry curriculum in those same grades. So now kids enter high school, and we need to do some review, no question. We need to, recognize they didn't all learn about system equations, and they still struggle with some things. But we're able to say that this common critical core curriculum means that we don't have to repeat Algebra 1 in Algebra 2. And then the second half of Algebra 2 is really a race through of all this new stuff with little data or statistics. And so what that does is it takes me to, if you'll let me share my screen, I think that I can do this. Where did it go? It went over here to window, and there it is. All right, so let me share that. So I'm going to send these slides to the CISA people, and they're going to put it in the list so that anybody can go and see this particular thing. But here's where I wanted to get to. All right, come back here. Nope. Whoop, there it is. Ready? What course? Oh my gosh, look at that. Unit 1, polynomial and rational functions. Unit 2, exponential and log functions. And then we do trigonometric and polar, and it's all not assessed because it's not critical in functions involving parameters, vectors, and matrices. This world would be wonderful if some 20, 25, 30, 35, 50% in some places, in some communities, in some districts mastered that kind of mathematics. Well, you all know, you are looking at the College Board pre-calculus curriculum. The College Board decided it can make some money. And so it's got this whole thing. I don't love the test. I think that it's got some positive aspects. I think that it is locking in some terrible things in order to prepare kids for the calculus test that needs to be changed. And I don't want to get into all that. But so there's College Board pre-calculus. Take a deep breath, right? What course is this? So how nice. Look at that. We've got functions, quadratics, Graphing and analyzing polynomial functions all seems pretty old. Graphing and solving radical functions, you want to puke, right? Exponential functions with all that stuff that goes on. Yeah, finally some parent functions that should have been done all the way through, right? Log functions, trig functions, and then some appropriate enrichment. And every one of you knows that that course is the race through Algebra 2. And so what I would like to do is say that if we know how much of that is repetitive from 7th grade, 8th grade, 9th grade, 10th grade, in any kind of Algebra 1 or ideally an integrated program, then when we get to 11th grade, look at this. There's Algebra 2 annotated. So we don't have to do functions except as they apply in general for other kinds of function. We don't need to do linear and graphing parent functions. I mean, if that's not clear by then, you're in big trouble. And so that's already done in grades 6 to 9. Quadratics, it's done in integrated 2. It's exactly appropriate, not done in 9th grade. It's done in 10th grade, right, where it makes some sense and it can be tied to some of the statistics and all those kinds of things. It needs some review. Okay, fine, needs some review. Go back and think about that, right? Graphing and analyzing, well, that's the AP Unit 1. Graphing and solving radical functions, I think we can be perfectly fine in this world by just skipping it. We just don't need to do that. Exponential functions, well, it's done a little bit in integrated 2 or in a 10th grade course, and then it's reviewed in AP Unit 2. There it is. Log functions, AP Unit 2. Think about how, if you go back to this core set of what is pre-calculus, well, then that's Algebra 2 with a little bit of dressing around it. And so, for people, go and pick and choose, right? What I'm suggesting is you could easily add, if you are crazy or you are committed or you can justify it, right? Think how you can add to this grade 11 transition from an integrated common in 10th grade course to a 12th grade calculus course. You want to add complex numbers or a deeper treatment of trig or composite, you have the opportunity. Base E, well, you're going to do that with the natural log and stuff, but you can go a little deeper, perhaps, although I think that, you can't do all of that before calculus anyway. Rates of change, end behavior, real modeling, conics and conic sections, although the College Board says, well, we don't think that stuff is all that critical. And so we can pick and choose, but there's some time to do it. And I think that this is what starts. We start by saying, why are we doing simplification of all these things? Why are we rationalizing denominators? Why are we doing all this polynomial arithmetic and theory? Right? I mean, why are we doing trig identities? Why are we not going deeper? Why are we doing synthetic division? Why are we not building understanding? Why are we wasting time with matrices, vectors, polar coordinates? Oh, they're wonderful. They warm my heart. But they have nothing to do with kids mastering what's important in this course and being prepared for college and the workplace in those kinds of ways. And so accordingly, and all I'm going to do is simply say that, Eric and I have played with this. We believe that you can talk about a teachable, a rational Algebra 2 pre-calculus that gets every single kid ready for calculus effectively, that basically parallels the College Board curriculum. And in our invigorating high school math book, we have the audacity to define the course. I mean, each of those units, there's series and sequences, bullet, 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 bullet. Go back, series and sequences, functions and inverse, right? And so in that book, we have a page. So you have one person buy it and you Xerox the pages and you share it. And then you tear it to shreds. Like all of the people that are using this are stopping and saying, we don't agree with this. Love it. Who cares? What about this? And we're going to move this here and do this. But at least we have a starting place. We have a focus so that to me is an Algebra 2 pre-calculus course that, let's go back, there it is, that fits into the calculus pathway. And so our dream, and it's no secret, Eric and I have a new book coming out in October from Solution Tree. We like Solution Tree because they tend to take their books and also link them to professional development and workshops. And so we are doing an implementation guide. I think the book is currently called, although I'm sure they're going to kill us on this, Moving Math from the 19th to the 21st Century, an implementation guide. And it is the how-to implement some of the things that people are struggling with. But if you look at that kind of pathways for 11th and 12th grade, you see right there under the calculus pathway, the course that we're talking about, which allows kids to then go take calculus. And then there's a statistics pathway, which needs to be there. And kids need to be ready for AP statistics as seniors. And that's one way to do it. And then there's quantitative literacy. And, we went into much greater detail into the data and the quantitative literacy in our new book, because people have said we don't understand that, but there are a whole lot of resources that are out there. And so all I'm going to say is that, that's what, Molly, you asked us to talk about. I know Eric has some additional ideas, because what's so beautiful about the way we work together is, he builds on my stuff, I build on his stuff, goes back and forth. But the status quo is simply not acceptable. And so that's fine. We may agree with it, but what do we do? And I just hope that this podcast, webinar, whatever, is a chance to better understand why the status quo is not acceptable and what we might do to start these discussions. We live in a world where schools are supposed to instantaneously change, implement. We're never given enough time for it. Eric and I believe it's a minimum of 4 years, and in many cases, 5 years to pull this off. Nowhere in our business have any of us ever been given 4 or 5 years to make major changes. It's like, here's the new book. Okay, here's the new curriculum. Go do it tomorrow. And that's just unprofessional and unacceptable, and is part of the reason why we're in this mess.
Let me just add one thing. I teed you up to something, Steve, and you didn't take the bait. I mentioned this a while back about how there's a straight line from quantitative literacy to democracy. And this is actually some brilliant words that actually Steve wrote. So listen to this straight line. It's like, what does democracy need? Democracy needs debate. What does debate need? Debate needs evidence. What does evidence need? Data. What does data need? The ability to be quantitative literate. So there's a straight line from quantitative literacy to democracy, because democracy needs debate, which needs evidence, which needs data, which needs quantitative literacy. And if we don't see that today in the world we live in, then we're not paying attention. Because everywhere we see quantitative literacy, or everywhere we see quantitative illiteracy. And that's why, go ahead.
All right. No, you finished.
And that's why more than ever, we need alternative pathways to the Algebra 2 that we've always done, or the Algebra 2 that Steve just outlined. We need those alternatives, because quantitative literacy and data analysis is the survival of our democracy.
So I'm sitting here in Washington, D.C. I'm here 10 to 14 days a month, and then we manage to be all kinds of other places. I'm not just in Washington. I'm sitting right now halfway between the White House and the Capitol. We're literally 7 blocks from the White House and 8 blocks from the Capitol. So one second, let me there. Yeah, that's right. There's that wonderful slide that Eric has got there. And so, there are 2 senators that live in the building. I'm on a first name basis with Sheldon Whitehouse and with Elizabeth Warren and all that kind of stuff. But this notion of a democracy and its link to mathematical understanding has never been clearer. People who don't understand probability are not going to make good decisions for themselves. People who don't have a sense of questioning data are going to just buy into all the crap that is being poured at us on social media on a regular basis. I actually am such a geek that I read about 60 of the 172 pages in the tariffs decision, because I had seen that Neil Gorsuch, not one of my favorite characters, but Neil Gorsuch made a really powerful case for powers and what the Constitution says and the justification for his thoughts. And I'm thinking, how many of my former students are able to understand that, make sense of it, have any interest in plowing through it? But we live in a world where every day, whether it's this insane war that we are prosecuting, or the impact of squeezing off the Straits of Hormuz 16,000 miles away, or it's on and on and on with the tariffs, with the ways in which we are chopping off healthcare. There was a piece just the other day. We have insurance. Almost all of us are lucky enough to have insurance, which means we don't know what it costs. We don't care what it costs. But the stuff in the paper the other day about people who go in for a 2-hour procedure and get a $77,000 bill. I mean, just stop and think, how do people do that? And all of a sudden, this is really personal. I mean, my 42-year-old son was diagnosed with thyroid cancer last week. Yes, it's malignant, but it's the best kind, and it's the slow growing, and it's got a 95% success rate, and you're going to do some surgery, and he's got good surgeons and all that kind of stuff. But I can't tell you how much data I have absorbed trying to make sense of what's going to happen to my kid. What do I need to know? And when I found out more about the needle biopsy, I knew even more. And he's got a consult with it. But the point is that we have insurance. He has insurance, and he'll be fine. But how people go through life without some of those things. And now when we talk about insurance and credit cards and things, we're talking about financial literacy, and we're talking about quantitative understandings. The fact that people don't understand that if you pay the minimum balance on your credit card every single month, you get further and further behind is just, it's a scam. And yet it's totally legal. So I think that those are some of the things that we know and have got to be built in.
Thanks for sharing some of those examples. I think it's lining up a lot with what we're hearing in districts too. And actually the graphic that you shared with the same courses, the integrated courses for 9th and 10th grade aligns with our local perspective for the Wisconsin standards. We have first 2-year standards. And then when we get to Algebra 2, that area, we have an opportunity, like you said, for students to make choices that are informed based on their future aspirations and career goals and what do they want to do post-secondary. And I think that that is the huge opportunity for growth. And I love that chart that's in your book that shows not only is it opportunities for kids to choose within high school, but those pathways that you have also align with what a lot of higher ed is doing too. So if a kid is jumping into that quantitative literacy, or like in our state, we've been exploring some ISQR with the data center, that integrated stats and quantitative reasoning, like
Great
that
course.
pathway, right? It encompasses a lot of what you're discussing right now. But that pathway is something that someone can continue with beyond their secondary education too.
So the mindset here is, what's the hierarchy? What's the power? I mean, as you well know, most people believe that the superintendents and the state board and the boards of education and the superintendents are on top. And then you work through all the middle managers, and then you've got the principals who are perhaps the most important people in the system and for all the things we're talking about. And then you get the teachers, and at the bottom of the barrel of the kids. I like to put it upside down. I think that this is all about the kids. The kids sit at the very top of the pyramid and second only, and then the teachers are second only to the kids. And that what we are doing is got to be less of this bottom up and more of this top down, from the sense of the kids are telling us with how they vote and, literally how they vote with their courses and their attitudes and their dispositions, right? And as teachers, we've got to, say, listen to the kids and hear them and recognize we're clinging to things that just are not critical. We all know as educators that if we taught 70% of the curriculum well, every kid would do well on every test we give them, even if we ignore the other 30%. But we're afraid to do that. And so we teach it all, race through it, and then we wonder why it is often a disaster. But this notion of where's the power, we've got to start, I think, because the average superintendent's got too much other stuff worried and doesn't really care unless the board comes and the board sort of thinks and then they change, and whether we worry about this or don't worry about this. The teachers have got to say, hey, here we are. We care about your kids. and we don't think they're being adequately served. We need your help. We need you to give us some permission. We need you guys to give us some money. We need to do this planning. This is what we're looking at. This is what we're talking about. When we win over our principal or the three principals in the three high schools, and we come to the assistant superintendent and say, bring the superintendent in because we don't want to play this hierarchical game. The two of you have got to buy into this. And then we, the teachers, will bring it to the Board of Education with our slides and with examples, and we will show them the difference between the AP calculus and the AP statistics and remind them that in this world, and we already have done some quiet pre-work with the two boards of education members that we know are on our side, and we have them jump in. That's the kind of way we have to play politics with some of this, and we do it district by district. We recognize that just because the state says something doesn't mean we have to do it. And the wonderful thing about what Trump has done in the Department of Education is no one's going to come and yell at you if you do any of this stuff. They don't really care about equity in Washington. They don't care about your curriculum. All they care about is charter schools. It's crazy. But I mean, I'm waiting for, it's another whole thing of trying to get state commissioners to take advantage of that opportunity. We need to do high stakes testing in the fall of fourth grade, sixth grade, and eighth grade. End of story. That's it. We do not need to test every year. That's a Texas abomination. We need to test in the fall because I don't want to hold people accountable. You're the only ones that are teaching it. No, they're not teaching. I want to know what's been retained over the summer. I want to know what with 3 weeks of school works. And so those are the kinds of things that I think we can take on in districts or pick and choose our battles. But if we don't, you all know either it's not going to happen or somebody that doesn't understand any of these things is going to impose it on us and expect us to do it tomorrow. And so that to me is a critical piece of this so that we are rational and use our vast experiences to gradually make this work. And CISA is critical because you guys are backup. You guys can show up in some of those meetings and some of those boards of education. You can talk about this is not just happening in such and such a community, but there are 4 communities that we're doing this now. And in fact, 2 communities are a year ahead of everybody else. And look what they're doing and look at how their test scores have already gone up some because they are doing some rational things. And that's the hope.
Yeah, and I think that's one of the main goals of having you on too, is just to get the word out there that things like this are happening nationally, but also locally. And we just need people to take that step in that direction to move forward with some of this modernizing of high school mathematics. Matt has been patiently waiting with his question here. So I'm going to invite Matt into the chat to elevate some of the feedback or questions that we've had from folks who are joining in. Matt?
Yeah, thanks, Molly. So one of the participants asked a question, and I think it speaks to a little bit about maybe messaging that students are getting and also their motivations. But question is in the past few years, students applying to college seem to be discouraged from submitting an application with an undecided major and maybe are pushed to apply to business school instead of undecided. The concern arises that many business schools like to see pre-calculus on a transcript. So that's pushing students to take pre-calculus instead of statistics in high school. The question is just simply, do we have any ways to address this, or what are your thoughts around that?
Well,
yeah, it's a game. Go ahead, Eric. You're a higher ed person. How do you handle this?
Well, again, there's a gray area. We talked about how STEM is going to continue to be an algebra 2 pre-calculus calculus. And there's no argument that kids going on the trades, communications, humanities, sociology, and psychology are going into an alternative pathway, a data science, quantitative literacy pathway. I don't think there's any argument there. I think business has always been a gray area for me. Like, does business need the STEM pathway, or does business need the statistics data analysis pathway? Look, if you talk to business professors, especially in my college, they would say, yeah, we want them rather have statistics and quantitative literacy. But I do think there's a little gray area where there's a lot of universities that business, they're still taking calculus. I think that is one gray area, but I don't think there's a lot of gray areas here. I don't know, Steve, how you feel about this business gray area, but there's a lot. The majority of majors, it's pretty clear if you're going to need a STEM traditional curriculum or a data analysis curriculum would do better for you.
So I just think that we have to be open, clear, and honest about it. I mean, college admissions is a game, and we have to figure out how to wisely play the game. We know that great guidance counselors and very expensive college placement consultants. I know that in a case in my family, we spent and split the bill between my kids and myself, $2,500 to have somebody do assistance with college placements, because the money's there and why risk it. But what she taught them is basically it's a game with a set of rules. So I think that, in fact, since there is no penalty for whatever major it is, I tell kids, my own family, I said, the last thing you want to do is claim you want to do business, economics, or English, because everyone wants to do that stuff. And so you ask the college, or you look for data about, so which majors are hungry, which majors are starving, which majors do not have a lot of people. And that's what I put on my thing. I mean, in my case, I really believed I was going to be a math major, but in fact, it worked out wonderfully. I mean, by declaring to be a math major, I got into Wesleyan early decision. It was really wonderful. And yet I got out of it pretty damn quickly. So I think that it is, again, a strategic game that one has to play with that, and that's not an inappropriate thing. But I would tell a kid, don't put English major down there, because there are too many English majors, and they have to have some scientists, and they have to have some music people, and they need to have others. That's the way I do it. Or if I'm thinking that maybe I might minor in art, I don't know, you look and you see what the statistics are. And I'm not saying anything that I don't know. Great guidance counselors in all the places do. I mean, we're talking about, the guidance counselors at the high-class suburban high schools that the parents all demand help them with their kid. And you've got it all over Wisconsin and all over the country.
I think your elevation of playing the game a little bit too. So if we think about how you've structured even this math 1-2 idea, and now we have this question because we know pre-calculus is something that we've sort of made up as a stepping stone between algebra 2 and calculus, is thinking about, we have the naming structure of math 1, math 2. If we have math 3, that could be your pre-calculus, and that's not necessarily on a transcript either. So your fourth year options then are AP Calculus. You go straight from Math 3 to AP Calculus, or AP Stats, or Quantitative Literacy, ISQR, any of those options. And there's sort of some gray area in there of whether or not maybe there's not even a pre-calc option in your course handbook, and you've checked that box now with semantics. And same with, we get in our state often Algebra 2, because there's certain universities that maybe have Algebra 2 in the language, but our state has local control and flexibility on what we determine is part of Algebra 2, because our standards just say all students need to take those first few years of unified mathematics curriculum. But then after that, we can sort of define what that looks like. So there's an opportunity for us to rethink even our naming sequences too. So it is a little bit of playing that game and providing the content that students need as well.
All I would do is worry about, it just seems like that's still required, that you got math 1, math 2, and then math 3. I would go and say, okay, there is integrated math 1, integrated math 2 for all students. That's 9th or 10th grade. Or in some cases, we still can accelerate. There are some kids that are ready to do it in 8th grade and 9th grade. That's fine. They can take 3 AP courses and all. But then we have algebraic math 3, and we have statistical math 3. Or data math 3. But I think it's critical that we differentiate them, because they really need different curricula.
Yep. Yeah, I would say that's what schools that I've worked with locally have sort of opted into, which is essentially, you described the Washington model or layout for the course sequencing. So it's having maybe that unified first semester of a modern Algebra 2, and then students are choosing that second piece too. So it's very interesting, and people are getting creative with some of those ideas too.
Yeah, it's really exciting. I mean, I've written lots of books and I've never hawked them. I've never sort of incorporated the books that I've written into any of the workshops and presentations and speeches I've done. It just always seemed inappropriate to be selling those kinds of things. But this is different. I mean, these books really are guidebooks. the mere fact that our invigorating high school math is selling so mediocrely says everything you need to know. It's one of the reasons why we wrote another book, because people are confused with it. People don't know what to do with it. There isn't any kind of real incentive to do it. And so it's not yet the answer. But I think both Eric and I believe that we're doing a better job of knocking on the door. But we're nowhere close to a critical mass on these issues yet.
Let me, I know our time's coming to a close here. Let me just make one last final remark here. It's very rare that major math organizations will come out with the same statement. But let me read the statement by these 5 organizations. The first organization is the American Math Association of Two-Year Colleges. That's APMAT. The second organization is the American Math Society, AMS. The American Statistical Association, ASA. The Math Association of America, MAA. And the Society for Industrial and Applied Mathematics, or SIAM. Every one of these organizations simply agrees that the status quo isn't acceptable anymore. 6 major math organizations all agree that we just can't keep doing the same old thing because we've always done the same old thing. It's time. It's 2026.
Look at how in sync we are. I knew Eric would end with that, and it just happens to be the thank you slide from us.
Yes, I think that was a perfect ending and some call to action, some urgency there too about changing the status quo. So thank you everyone for joining us tonight and for asking questions in the chat. I'm going to hand it over to Mitchell here. And also, obviously, thank you very much to Eric and Steve for joining us. We hope to see you in the future as well. And Mitchell is going to take us with an outro here. So Mitchell.
All right. Well, just to reiterate, I just want to thank everyone as well. Thanks for joining live. Thanks to those that are listening asynchronously afterwards on Spotify or wherever you get your podcasts. The links and resources will be available in the description of the podcast. It will be available on our website. If you wanted to watch this podcast, Steve did share a screen. That will be available on YouTube, so check that out over there. But again, Steve, Eric, thank you so much for the conversation. Matt and Molly, thanks again for hosting a great conversation. It's the year of math, and we'll continue hosting things like this. If you want to stay updated on all things CISA 2, and if you want to stay engaged with the Building Educator Capacity Podcast, please subscribe wherever you get your podcasts. We'll see you next time.
That's great. And I will send you the slides in about 40 seconds.
All right. Thanks, everybody.
All right. Bye. Thank you.